This example is going to demonstrate the application of the limit laws. Don't forget, the supposition for the limit laws is that the limits of the functions have to exist before you can combine them and use them together using these limit laws. So we'll keep that in mind. In this graph, our g function is kind of a straight line, but there's a disconnect and a jump between them at x equals -3. That's a g function. While the f function is a curvy dude that moves around and has a few holes in it. And they're asking us to find the limit as x approaches some particular numbers of a combination, some certain combinations of these functions. Okay, so let's get started here. Part A, we're going to find the limit as x approaches -3 of 3f of x plus g of x. Well, first notice that the limit as x approaches -3, look at the graph, of f of x is the y partner, y equals 6. That's cool. Everything's fine. Y is equal to 6. That's defined. The limit's defined. And the problem is actually going to arise when we look at the limit as x approaches -3 of the g function. Remember, the g function is that line that has the big gap in it, and it happens to have that gap at x equals -3. When you consider the limit when x approaches -3 from the negative side of g of x, that limit's equal to +3. That's a y partner that it approaches. But as you approach -3 from the positive side, you're crawling up on that graph, and the y partner you're approaching is y equals +1. Now there's disagreement here. The left and right side limits don't agree. That means the limit as x approaches -3 in general, it does not exist. Now, since it doesn't exist, we don't meet the criterion to use any of the limit laws, so we cannot use the law that tells us that the limit of a sum is the sum of the limits. So at this point, we just say that this limit of this new function 3f of x plus g of x just doesn't exist. For part B, they want us to find the limit of a product. First, notice that the limit as x approaches -1 of f of x, look at the graph, the y partner is getting close to 2. And that's just in general. We're not even looking at left or right. And similarly, for the limit as x approaches -1 of g of x, the straight line with the jump in it, that equals -2. Okay, well then they do exist, and that implies that the limit as x approaches -1 of the product f of x times g of x is equal to the product of the limits, the limit of the f of x times the limit of the g of x. And we can say that because of the limit law number 3. And that will be equal to, well, it's going to be equal to the first factor, the limit as x approaches -1 of f of x, that's 2, times the second factor, the limit as x approaches -1 of g of x, -2. 2 times -2, that equals -4. We're done. And part C, they want us to find the limit of a quotient g of x over f of x as x approaches 0. Well, first notice that the limit as x approaches 0 of g of x is -4. Everything's cool there. But the limit as x approaches 0 of f of x, the curve, well, look what happens on the curve as we approach 0. As we approach 0, the answer is 0. The y partner is 0. Okay, well, we cannot use law number 4, the quotient law, because in order to use it, you have to have the limit of the denominator in the denominator has to not be equal to 0. This one does have it equal to 0, so our answer is undefined. It does not exist.